Insanity is coming, the dawn of autonomous scientific discovery. Introduction. The landscape of scientific inquiry is on the brink of a revolution, one that promises to redefine our understanding of innovation and discovery. Recent discussions among thought leaders in technology and science have highlighted the imminent rise of autonomous scientific discovery driven by advanced artificial intelligence (AI). This movement is not merely a theoretical proposition, it is backed by an increasing number of research papers and practical applications that suggest we are entering an era characterized by unprecedented acceleration in scientific progress. The emergence of AI scientists. The foundation of this impending transformation lies in the concept of AI scientists, software entities capable of conducting research, formulating hypotheses, and drawing conclusions without human intervention. Dr. Singularity, a prominent voice in this discussion, asserts that we are approaching a scenario where billions of AI scientists will be available at our disposal. The scalability of software means that these AI systems can be replicated endlessly, leading to an exponential increase in research output. The implications of this are staggering. If AI can conduct experiments and analyze data as efficiently as or even better than human researchers, the rate of scientific advancement could increase by at least 1,000 times. Dr. Singularity posits that in a matter of months we could achieve more progress than humanity has seen over the course of 2 centuries, from 1800 to 2025. Exponential growth and the singularity. This concept ties closely to the notion of the singularity, a term popularized by futurists to describe a point in the future when technological growth becomes uncontrollable and irreversible. At this juncture, the advancements in AI could lead to self-improving systems that surpass human intelligence, fundamentally altering our society. The potential for a 1000x increase in research output suggests that we are not merely witnessing an incremental change but rather a paradigm shift in how scientific discovery is approached. Current evidence of AI's capabilities. Dion Hinchcliffe, another influential figure in the conversation, has observed that AI is already capable of leading scientific discovery and technological invention. He notes that there is an increasing body of evidence supporting the idea that AI's role in scientific inquiry is burgeoning. Major breakthroughs are starting to emerge from AI-driven research, showcasing the potential for these systems to make significant contributions to fields ranging from medicine to environmental science. As AI tools become more sophisticated, the ability to analyze vast datasets, recognize patterns, and generate hypotheses will enable a new level of inquiry that was previously unimaginable. This capability could lead to breakthroughs in understanding complex systems, developing new materials, or even finding cures for diseases at an accelerated pace. Scalability and research output. One of the most compelling aspects of this AI-driven scientific discovery is its scalability. Traditional scientific research is often constrained by human limitations, time, expertise, and resources. In contrast, AI can operate around the clock, processing information and generating results at a pace that far exceeds human capabilities. This scalability means that rather than a handful of researchers working on a problem, thousands or even millions of AI systems could be tackling various scientific questions simultaneously. The result would be an unprecedented proliferation of research papers, innovations, and technological advancements. The scientific community could see a dramatic increase in the volume of discoveries made within a short time frame, radically shifting the landscape of knowledge and understanding. Community engagement and public discourse. The excitement surrounding autonomous scientific discovery is not confined to academic circles, it has permeated social media and public discourse. Users on platforms like Twitter and Reddit are actively engaging in discussions about the implications of AI in science. The growing interest reflects a collective curiosity about how AI will reshape scientific paradigms, ethical considerations, and the future of research. This engagement is essential as society grapples with the potential impacts of AI. It prompts important questions. How do we ensure that AI is used responsibly in scientific research? What ethical guidelines should govern autonomous discovery? The public's involvement in these conversations is critical for developing a framework that maximizes benefits while mitigating risks. Conclusion. In summary, the convergence of AI and scientific discovery heralds a new era of rapid innovation and advancement. The prospect of autonomous scientific discovery driven by billions of AI scientists suggests that we are on the cusp of a major breakthrough in how we approach research and knowledge creation. As we move forward, it is essential to remain vigilant and engaged, ensuring that the developments in AI are harnessed for the betterment of humanity. As we stand at this precipice, the sentiment echoed by Dr. Singularity resonates: insanity is coming. This phrase encapsulates the excitement, uncertainty, and transformative potential of autonomous scientific discovery, a journey that promises to redefine the boundaries of human knowledge and capability. The future is not only bright, it is accelerating toward a horizon that challenges our very understanding of science and discovery. The content revolves around the transformative potential of autonomous scientific discovery driven by artificial intelligence (AI). It emphasizes the anticipated acceleration of scientific progress, suggesting that we may soon witness an unprecedented number of discoveries at a pace far exceeding historical benchmarks. Here are some counterintuitive insights that emerge from the topic. 1. Scaling knowledge versus human limitations. The idea that AI can replicate and scale scientific inquiry challenges the traditional notion that human researchers are the primary drivers of innovation. This raises questions about the value of human intuition and creativity in scientific discovery. While we often think of scientific progress as a gradual accumulation of knowledge through human effort, the prospect of billions of AI scientists suggests a shift towards a model where sheer computational power and data processing capabilities overshadow human ingenuity. 2. Exponential growth perception. The claim that we could see more progress in a few months than in over 2 centuries is counterintuitive because it undermines the historical context of scientific progress. Historically, significant advancements took time due to the complexities of experimentation, peer review, and validation. The assertion that AI could compress this timeline significantly challenges the perception of how knowledge builds upon itself and raises concerns about the implications of such rapid advancement on the scientific method itself. 3. Quality versus quantity of discoveries. The focus on the volume of discoveries that AI could produce may lead to a devaluation of scientific rigor. While the prospect of rapid discoveries is exciting, it raises concerns about the quality and reliability of those discoveries. The scientific community traditionally emphasizes thoroughness and validation, yet the rapid pace of AI-driven research may prioritize quantity over quality, leading to a potential crisis in trust and verification in scientific literature. For a democratization of science, the notion that anyone could access AI scientists to conduct research could democratize scientific inquiry. But it also poses risks. It could lead to an influx of unqualified individuals generating research without the necessary expertise to interpret or validate their findings. This could create an environment where misinformation proliferates, challenging established scientific authorities and potentially undermining public trust in science. 5. Implications for employment and expertise. The rise of AI scientists suggests a future where traditional roles in research may become obsolete. This counters the expectation that advancements in AI will augment human capabilities. Instead, it raises concerns about displacement within the scientific workforce and the need for new models of collaboration between human researchers and AI systems. The idea that AI could replace human researchers in significant ways challenges the prevailing belief in the irreplaceable value of human expertise. 6. Ethical and regulatory challenges. The rapid pace of AI-driven discoveries could outstrip the development of ethical guidelines and regulations governing scientific research. This tension between innovation and regulation introduces a counterintuitive dynamic where the push for rapid advancement might lead to ethical breaches or misuse of scientific knowledge. The urgency to harness AI's potential might overshadow necessary discussions on ethical implications, safety, and societal impact. 7. Changing nature of scientific inquiry. The shift towards autonomous discovery implies that the nature of scientific inquiry itself could change drastically. Traditional methods of hypothesis-driven research may be supplanted by data-driven approaches where AI identifies patterns and insights without human intervention. This raises questions about the role of scientific curiosity and the fundamental processes of inquiry that have characterized human research for centuries. These counterintuitive insights reflect the complexities and potential challenges accompanying the rise of AI in scientific discovery. While the prospects for accelerated progress are exciting, they invite deeper consideration of the implications for the scientific method, the workforce, and society at large. The concept of autonomous scientific discovery is gaining traction, highlighting a paradigm shift that has the potential to drastically alter the landscape of scientific inquiry and innovation. As AI technology continues to evolve, the implications of its integration into scientific research are profound and multifaceted. While many aspects of this development are being discussed, there are several important components that often go overlooked. Here we will delve into these significant aspects and explore why they are crucial for understanding the future of scientific discovery. 1. The implications of billions of AI scientists. The notion that we will soon have billions of AI scientists is more than just a catchy phrase. It represents a fundamental shift in how scientific research is conducted. The scalability of AI means that research efforts can be multiplied exponentially. This has several implications. Diversity of research, with billions of AI scientists operating simultaneously. A wider array of scientific questions can be explored. This diversification could lead to breakthroughs in underfunded or overlooked areas of research that human scientists may not prioritize due to resource constraints. Collaborative intelligence. Autonomous AI systems can collaborate in ways that human researchers cannot. They can share data and findings instantly across vast networks, leading to faster synthesis of information and more informed hypothesis generation. Resource allocation. The traditional model of scientific research often requires significant funding and resources. AI scientists, being software-based, can operate at lower costs and streamline research processes, making it feasible to conduct high-quality research in resource-limited environments. 2. The nature of accelerated discovery. The claim that we could see 1000x faster progress raises questions about the nature of scientific discovery itself. This acceleration is not merely about speed, it alters the very definition of what it means to conduct science. Shift from human-centric to machine-centric research. As the role of AI in scientific inquiry grows, there may be a shift in the foundational principles of scientific methodology. Traditional methods that rely heavily on human intuition, creativity, and serendipity may be complemented or even replaced by data-driven approaches that prioritize algorithmic efficiency. Ethical considerations and accountability. The deployment of AI in research raises ethical questions regarding accountability and the integrity of the scientific process. If an AI system generates a discovery, who owns that knowledge? How do we ensure that AI systems adhere to ethical standards in research, particularly in sensitive areas like genetics or medicine? 3. The role of human oversight. Despite the excitement surrounding AI's potential, the significance of human oversight cannot be understated. The integration of AI into scientific discovery does not eliminate the need for human researchers, rather it redefines their role. Interpretation and context. AI can process vast amounts of data and identify patterns, but the interpretation of these results still requires human context. Human researchers are essential for providing the nuanced understanding necessary to validate findings and apply them responsibly. Quality control. As scientific output accelerates, the risk of errors or false findings may increase. Human oversight is crucial for quality control. ensuring that the research produced by AI is rigorously vetted and meets established scientific standards. 4. Public engagement and understanding. The discourse surrounding AI and scientific discovery is not confined to academic circles, it has permeated public discourse, particularly through social media platforms. This engagement is significant for several reasons. Democratization of science. As more people become aware of the implications of AI in science, there is potential for a more democratic approach to scientific inquiry. Public interest can drive funding and support for diverse research areas, potentially leading to innovations that reflect a broader societal need. Addressing misinformation. Increased public engagement also presents challenges, particularly in combating misinformation. The fast-paced nature of AI-driven discoveries can lead to misunderstandings about the science involved, necessitating a proactive approach to science communication. 5. Long-term vision and sustainability. The excitement surrounding autonomous scientific discovery often overlooks the importance of sustainable practices in the development and implementation of AI technologies. Environmental considerations. The computational power required for AI-driven research can have significant environmental impacts. It is crucial to consider sustainable practices in the design and deployment of AI systems to mitigate their carbon footprint. Long-term impacts on employment. While AI may enhance productivity and efficiency, it is essential to consider the long-term implications for employment in the scientific community. The potential displacement of human researchers raises questions about how to integrate AI into the workforce without compromising job security and professional development. Conclusion. The concept of autonomous scientific discovery heralds a transformative era in scientific research driven by the scalability and efficiency of AI technologies. While the potential for accelerated progress is exciting, it is essential to recognize the complexities that accompany this shift. The implications of billions of AI scientists, the nature of accelerated discovery, the necessity of human oversight, the importance of public engagement, and the need for sustainable practices are all critical considerations that warrant attention. As we stand on the brink of this new frontier, it is vital for both the scientific community and society at large to engage thoughtfully with these developments, ensuring that the integration of AI into scientific discovery serves the greater good and fosters a responsible and ethical approach to research. The excitement surrounding autonomous scientific discovery is not merely about speed, it is about redefining the very nature of inquiry and the collaborative future of science. Here are the 4 most valuable points for in-depth analysis and discussion regarding the topic of autonomous scientific discovery and its implications. 1. Exponential acceleration of scientific progress. The notion that AI could accelerate scientific discovery by at least 1,000 times is a groundbreaking concept that deserves careful scrutiny. This idea suggests that the rate of innovation could surpass any historical precedent, including the tremendous achievements from 1800 to 2025. This acceleration raises several questions. What metrics will be used to measure this progress? Understanding how we quantify scientific advancements is crucial. Will we focus on the number of discoveries made? The impact of these discoveries or their applications in real-world scenarios? What are the implications for existing scientific paradigms? An accelerated pace could disrupt traditional research methodologies, potentially leading to a paradigm shift in how science is conducted. This could challenge the existing educational frameworks and the roles of researchers. Could this lead to ethical dilemmas? Rapid advancements may outpace our ability to understand their consequences, raising ethical considerations about the use of AI in potentially sensitive areas like medicine or environmental science. 2. The role of AI in autonomous discovery. AI's capability to conduct autonomous scientific discovery is not only a technical marvel but also a transformative force in research. The insights from Dion Hinchcliffe highlight that AI has already begun to take the lead in significant discoveries and innovations. This point necessitates exploration of Examples of AI-driven discoveries, documenting specific instances where AI has led to breakthroughs, can illustrate its potential. For instance, AI's role in drug discovery or climate modeling can serve as case studies. Human-AI collaboration. While AI can operate autonomously, the dynamics of how it collaborates with human scientists are vital. What roles will human researchers play in this new landscape? Will they become overseers? Or will their roles evolve into more creative and interpretive functions? Quality versus quantity of discoveries. An increase in the volume of research papers is expected, but does this guarantee quality? Discussion should focus on how to maintain rigorous standards in scientific research amidst the influx of AI-generated outputs. 3. Scalability of AI scientists. The scalability of AI systems represents a revolutionary shift in the scientific landscape. The ability to deploy billions of AI scientists raises important considerations. Resource allocation. With an abundance of AI scientists at our disposal, how will resources, such as funding, data, and infrastructure, be allocated? This could lead to a shift in how research priorities are set. Intellectual property. The proliferation of AI-generated research may complicate ownership and authorship issues. Who owns the findings generated by AI? This question will likely spark debates about intellectual property rights in science. Global collaboration. The scalability of AI scientists could foster unprecedented collaboration across borders. However, it also raises concerns about data privacy, security, and the potential for unequal access to AI technologies in different regions. 4. Public engagement and discourse. The increasing discussions about autonomous scientific discovery in social media and public forums indicate a growing interest and concern among the general population. This point emphasizes the need for educational initiatives. As public interest grows, there is an opportunity to enhance science literacy regarding AI and its implications. How can we educate the public about the benefits and risks of AI in science? Inclusive dialogue. Engaging diverse voices in the conversation about AI's role in scientific discovery is critical. This includes not just scientists and technologists but ethicists, policymakers, and the public. How can we ensure that a range of perspectives is considered in the shaping of policies around AI in science? Monitoring and regulation. As autonomous discovery becomes more prevalent, there will be a greater need for regulatory frameworks to manage the implications of AI in scientific research. What measures should be implemented to ensure ethical practices in AI-driven research? In conclusion, the advent of autonomous scientific discovery driven by AI presents profound opportunities and challenges. Each of these points warrants deep analysis and discussion, as they will shape the future of science and its role in society. The excitement surrounding these developments should be tempered with careful consideration of the ethical, social, and practical implications that arise as we stand on the brink of this monumental shift. 1. The Industrial Revolution. This period, spanning from the late 18th century to the early 19th century, marked a major turning point in history. It was characterized by a shift from agrarian economies to industrialized ones, facilitated by advancements in technology and machinery. The invention of steam engines, mechanized looms, and other innovations enabled mass production, fundamentally transforming society, economics, and the environment. The rapid increase in productivity and the rise of factories drastically changed labor dynamics and urbanization. Similar to how AI has the potential to transform scientific discovery and research methodologies. 2. The Manhattan Project. This World War II-era project was a secret endeavor by the United States to develop nuclear weapons. It brought together some of the greatest scientific minds of the time, including physicists like J. Robert Oppenheimer and Enrico Fermi. The project epitomized the power of concentrated scientific effort and collaboration, leading to groundbreaking advancements in physics and engineering. The urgency and scale of the project, along with the innovative use of scientific methods, parallel the anticipated rapid advancements in scientific discovery driven by autonomous AI systems. 3. The Human Genome Project, initiated in 1990 and completed in 2003. This international research initiative aimed to map all the genes of the human species. It was one of the largest collaborative biological projects ever undertaken, involving scientists from around the world. The project not only provided a complete sequence of human DNA but also revolutionized the fields of genetics and biotechnology. This endeavor's collaborative and expansive nature mirrors the envisioned role of AI in conducting autonomous scientific discovery, where many AI entities could work simultaneously on complex problems, leading to accelerated advancements in genomics and other scientific fields. The future of scientific discovery is on the brink of a revolutionary transformation, primarily driven by the advent of autonomous scientific discovery powered by artificial intelligence (AI). As we look ahead to the next decade, the implications of this shift could be profound, ushering in an era of unprecedented acceleration in research innovation and problem solving. The rise of AI scientists. AI's capability to perform scientific research autonomously means that we can expect to see billions of AI scientists contributing to various fields. Unlike human researchers, AI can be replicated and scaled without the limitations of physical resources or time constraints. This scalability will enable a vast number of experiments and analyses to be performed simultaneously, leading to discoveries at a speed that vastly exceeds current capacities. Exponential progress in discovery. Predictions indicate that we could see a 1,000-fold increase in the pace of scientific progress. This means that in a single month the output of meaningful discoveries could surpass what humanity achieved over 2 centuries. From 1800 to 2025. Such acceleration could redefine our understanding of fields ranging from medicine and environmental science to physics and engineering. The term singularity is often invoked to describe this point where technological growth becomes uncontrollable and irreversible, leading to unforeseeable changes in human civilization. Transformative effects on research methodologies. The nature of scientific inquiry will shift dramatically with AI at the helm. Traditional research paradigms, which often rely on hypothesis-driven experimentation and peer collaboration, will evolve into more dynamic and iterative processes. AI systems could autonomously generate hypotheses, design experiments, analyze results, and even propose new avenues of exploration based on their findings. This shift could lead to a more fluid and rapid iteration of scientific theories and applications. Democratization of knowledge and research. The proliferation of AI scientists will also democratize access to scientific research. As AI tools become more accessible, researchers from diverse backgrounds and institutions, including those in underfunded or developing regions, will be better equipped to contribute to global scientific conversations. This could lead to a more inclusive scientific community where a broader range of voices and ideas are represented. Collaboration between human and AI researchers. While AI will play a central role in future scientific discovery, collaboration between human researchers and AI will remain essential. AI can handle large data sets and complex simulations that would overwhelm human capacities, but human intuition, ethical considerations, and creativity will still be crucial in guiding research priorities and interpreting results. This symbiotic relationship could enhance human capabilities and lead to more nuanced and responsible scientific practices. Ethical considerations and challenges. As we embrace autonomous scientific discovery, ethical considerations will come to the forefront. Questions about accountability, bias in AI algorithms, and the potential for misuse of scientific discoveries will need to be addressed. Regulatory frameworks will need to evolve to ensure that AI-driven research adheres to ethical standards and benefits society as a whole. Implications for education and workforce. The educational landscape will also need to adapt to this new reality. As AI takes on more research responsibilities, the skills required for future scientists will shift. Educational programs may need to focus more on interdisciplinary approaches, data literacy, and collaboration with AI systems rather than solely on traditional scientific methodologies. Conclusion: a new era of scientific inquiry. As we stand on the cusp of this new era, the potential for autonomous scientific discovery heralds a future filled with possibilities. From medical breakthroughs that could eradicate diseases to innovative solutions for climate change, the implications of this technological advancement are vast and far-reaching. The integration of AI into the scientific process promises not only to expedite discovery but also to reshape the very foundations of how we understand and interact with the world around us. In summary, the future outlook for scientific discovery is one of rapid acceleration, transformation, and democratization driven by the capabilities of artificial intelligence. As we navigate this exciting new frontier, it is imperative that we remain vigilant in addressing ethical concerns and fostering collaboration between human and AI scientists. The journey ahead holds immense promise and the potential to redefine not just science but the future of humanity itself.